So far, we have discussed two ways in which we can deal with our dependent variable being a categorical variable. The first was a linear probability model, LPM, but it suffered from several drawbacks, which is why we shifted our attention to another type of model, which was called the logit model. The logit model basically uses the cumulative distributive function of a cumulative logistic function. It describes a way in which probability that the value of yi is equal to 1 is related non-linearly to the values of the explanatory variables xi. The Probit model also uses a similar logic, except here we use the cumulative distributive function of a normal distribution. Hence, the Probit model is also known as a normit model. Right? The main difference between the Probit and the logit model is the type of cumulative distributive function that it uses to estimate the probability of the variable yi being equal to 1. Okay. Now, the logic underlying the Probit model, we are continuing with the home ownership example so that we understand how it works. Now, the logic behind the Probit, also known as the normit model, is that there is some utility index ii for the ith family. This utility index is unobservable, okay, and it is determined by the values of the explanatory variable xi. So in our example of home ownership, the utility index ii is a function of the explanatory variable xi, which is income. So larger the value of the index ii, the greater is the probability. Larger the value of ii, the greater is the probability that the dependent variable yi equals to 1. In our example, that the family owns the house in which it is staying. Okay. Now remember, this utility index ii is an unobservable index. So how do we relate this index to the actual decision of whether or not to own a house? Remember, in this example, y is equal to 1 if the family owns the house and y is equal to 0 if it does not own the house. So we assume that there is some critical index value, which I am calling I star. And if the ith family's utility index exceeds the value of I star, then we are saying that the family will own the house. In more general terms, we are saying that if the utility index exceeds the critical utility index, that would mean that the dependent variable has the value 1. Okay. Now remember, II is not directly observable, so the threshold II star will also not be observable. But we are assuming that this variable, utility index II, takes a normally distributed, follows a normal distribution, and both I star and II have the same mean and variance. It is this assumption that helps us to estimate the parameters beta 1 and beta 2 of the index. So how do we go about? We are saying that the probability of owning a house in our example, which can be written as the probability that y equals to 1 given the value of x, that is the income level, will be equal to the probability that the threshold utility index is less than or equal to the family's utility index. So as long as the family's utility index is crossing the threshold level, it will tend to own the house, right? And so we are saying, and remember we are saying that this variable II follows a standard normal distribution. So it is the probability that Zi is less than or equal to beta 1 plus, one second, beta 1 plus beta 2 xi, which basically means that we are assuming that Pi follows or is a function, the probability that y will be equal to 1 given the value of x will be a function of beta 1 plus beta 2 xi. Remember here Zi denotes the standard normal distribution, which has mean 0 and variance sigma square. So the cumulative distributive function is defined as 1 by root under 2 pi going from minus infinity to the family's II, unobservable utility index, e to the power minus z square by 2 dz. This is from the definitions of cumulative distributive function of a standard normal variable. Okay, this is the standard formula that we study as the cumulative distributive function of a standard normal variable. So here I can just write this more clearly as 1 by root 2 pi integration limits going from minus infinity to, instead of I can write it as beta 1 plus beta 2 xi. Remember we started off with saying that the utility index is equal to beta 1 plus beta 2 xi is a function of the explanatory variable, e to the power minus z square by 2 dz. So here Pi represents the probability that the dependent variable yi will be equal to 1. In put it more formally, it represents the probability that an event will occur. In our example, that the family will own the house. Okay, and this cumulative distributive function will give us the cumulative probability, or the total area under the standard normal curve from minus infinity to the II, utility index II. Now remember, we want to know how we can calculate II and as well as beta 1 and beta 2. So we had ended up in the last slide, what I had written was Pi can be represented as a capital F, that is cumulative distributive function of beta 1 plus beta 2 xi, that is my utility index II, and it follows the standard normal distribution. So I'm in effect saying that Pi is a function of the utility index II, since I had started off saying that II is equal to beta 1 plus beta 2 xi. So if I want to find II, all I need to do is find the inverse function of Pi. Therefore, my beta 1 plus beta 2 xi is actually the inverse of the functional inverse of the normal cumulative distribution function. So what all this means is, if I'm drawing my standard normal distribution where the probability Pi is this is a cumulative distribution function, that's why I'm using capital F. So it's a function of II, and I hope you remember that the cumulative distribution function will always be like that, where it meets the level of 1 asymptotically, that is at infinity, right? So if you have the value of II given to you, in that case you can always read from the standard normal distribution curve, cumulative distribution function, you can read the probability Pi as the probability that the threshold level of the utility index is less than or equal to the ith family's utility index. And so given the value of II, you can always find the probability associated with y taking the value of 1. And by the same logic, here is your cumulative distributive function the limiting values here are obviously minus and plus infinity, and on the y-axis it is from 0 to 1. Here the parallel line here is 1. Remember, your probability will always lie between 0 and 1. So your cumulative probability distribution, the maximum value, will also be nearing 1. So using the standard normal distribution curve, if you have the probability of owning a house given to you, you can estimate the utility index as from the function by reading the value from the x-axis. Corresponding to the given probability pi, you can read off the x-axis, you can read the value for the utility index ii, because ii is the inverse function of the probability pi. Let's have a quick look of how we'll go about estimating using the Probit model, estimating the PRF using the Probit model. The logic is somewhat similar, quite similar to estimating using the Logit model. Like we said, in that case, we can have two types of data. You can have individual data or micro level data, or you can have grouped data. Now, similar to the case of the Logit model, if you have individual data, we run into the same problems as we run into in the case of the Logit, and our model will not be linear in parameters, so you will need to use non-linear estimation techniques, namely maximum likelihood is one of the most favored methods of estimating the Probit model when you have individual data. But if you have grouped data, remember that means that for any income level xi, you have capital Ni number of families, of which small ni represents the number of families who actually own the house at the income level xi. In that case, you can estimate the probability pi from the sample as small ni divided by capital Ni. So far, our step or our procedure is same as the Logit model. Now, in the Logit model, we calculated the logit or capital L as the log of odds ratio. Here, we will use this information of the pi hat, that is the sample probability values corresponding to each income level xi, and calculate the utility index ii. Remember, the Probit model assumes that the utility index as well as the threshold level of utility follows a standard normal distribution. So from the cumulative distribution frequency, CDF function of the normal distribution, you can actually find the index values or the I values corresponding to each of the pi hats. So once you have the observed or the estimated ii, estimating beta 1 and beta 2 will be done in the regular manner by running the regression beta 1 plus beta 2 xi. Now, one thing that you do need to remember is that the unobservable utility index ii is called, it has a technical name which is the normal equivalent deviate. Deviate, small ned, or simply the normit. And if you remember, the normit or the standard normal distribution has a mean equal to 0. So anywhere where the probability is less than 0.5 or the probability is less than 50%, the value of the utility index II will be negative. Now, to get rid of this uncomfortable negative number, what often happens is we add 5 to the normal equivalence deviate, that is to the II, and this result 5 plus NED is called the Probit. So if you add 5 to the normate, you will get what is called the Probit, hence the name Probit model. However, Probit and normate, the terms can be used interchangeably. So once you have found the II value as either the normate or the Probit, II is equal to beta 1 plus beta 2 xi. This function can be estimated as usual in the same straightforward manner.